using the Sine Area Rule with Tutor. Here are the beginner questions, some of the easier questions that you're likely to find on this topic. The Sine Area Rule is a method to calculate the area of a triangle when two sides and the included angle are known. When we say the two sides and the included angle, we mean the angle that's formed between the two given sides, or sandwiched in between them. In this case, the formula for the area of the triangle would be equal to half AB sine of capital C, where A and B are the lengths that sandwich the angle in between them, labelled as C. It's particularly useful if you have a question where the base and a perpendicular height are not known and you're not able to use the conventional half base times the height. The formula is derived from this general formula for the area of a triangle, instead using trigonometry to replace the height with sine of the angle. So for the first question, the area would be half of A times B. It doesn't matter which way round you label the two lengths, 8 and 10, multiplied by sine of the angle formed between them, 23 degrees. Typing this into my calculator gives me an area of 15.63 meters squared. For the second question, I have two sides, 5 and 9, with the angle formed between them of 48 degrees. Half multiplied by 5 multiplied by 9 multiplied by sine 48 is 16.72, rounded to 2 decimal places, centimeters squared. On to the intermediate questions, with a slight increase in difficulty and those more likely to appear on the exam paper. We have a non-right angled triangle with one length labelled as 10, but we do not know another length with an angle formed between the two of them. I can use my knowledge of the sine rule to work out this length. I'll label this length as x. X is unknown, but I have the opposite angle provided. I also have another pair of opposite angle and length. Since I'm finding the length, I'll want to use the version of the sine rule where we have the length at the top of the fraction. A over sine A is equal to B over sine B, where A is the unknown length, labelled x. Capital A is the opposite angle, 49. B is the other length, and uppercase B is the opposite angle of 84. Multiplying both sides by sine 49 will provide me with x. So x is equal to 10 multiplied by sine 49 over sine of 84. X is equal to 7.5886. Now I know this length, I can find the missing angle inside the triangle using angles in a triangle add up to 180 degrees. Subtract the other two angles to give us 47 degrees. That means the angle formed between the two lengths is 47. And now I can use half AB sine C, where A and B are 7.5886 and 10, and the angle formed between them is 47. Typing this into my calculator and rounding to three significant figures gives me 27.7 centimeters squared. For the second question, I have all of the lengths, so using any of the two lengths, I can find the angle formed between them by using the cosine rule. I will label this as theta. Since the opposite length is known, along with the other two lengths, I can substitute into the version of the formula where we have the angle that forms part of the subject. So cos A equals B squared plus C squared minus A squared over 2BC, where capital A is theta, the angle to be found. B and C are the other two lengths not opposite the angle, and A is the length opposite the angle of 13. So this would be divided by 2BC, which is 2 multiplied by 9 multiplied by 15. I can use the inverse function to work out theta. So theta would be equal to cos to the negative 1 of the calculation. This gives me an angle of 59.5087. We won't want to round this number too soon to avoid rounding errors with our final calculation. Now the two lengths with the angle formed between them are known, I can use the sine area rule. Half of AB multiplied by sine of the angle I've just calculated is equal to 58.2 meters squared. On to the advanced question, one of the trickier questions that you're likely to find on this topic. This time, the area of the triangle is actually given as 42 centimeters squared. and the question wants us to find the length of AB, which is this length here. Since this length is already known, and I've been provided this angle of 70 degrees, I can use the sine area rule to work backwards and find the length BC, which I'll label as x. The formula for the area of the triangle is half AB sine C. So a half multiplied by the two lengths that form the angle, 7 and x, multiplied by sine of the angle 70, which is equal to the area of 42. Now I have an equation formed. I can use the inverse to work out x. 42 dividing by a half, dividing by 7, and dividing by sine 70 gives me a length for x of 12.7701. Now I know the other two lengths, and I'm working out the length that's opposite the angle of 70, which I will label as y. I can now use the cosine rule to find this length. I want to use the version of the formula where part of the length is given as the subject, a squared, which is equal to b squared plus c squared minus 2bc cos of the opposite angle. Lowercase a is the length to be found, labelled as y. B and c would be the other lengths of 7, and the one worked out of 12.7701 minus 2 lots of 7 multiplied by 12.7701 multiplied by sine of 70. This gives me a value for y squared of 150.928. Square rooting would give me y, which is 12.3 centimeters, rounded to 3 significant figures. Here's a question that I completed earlier. It appears as though I've made some mistakes. Pause the video and let's see if you can spot what they are and write some corrections in the comments below.
Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with topics or finding maths difficult, subscribe and turn on notifications to receive regular updates about new video tutorials and other useful content. You can visit and follow all of my socials by clicking the links in the description below.